let's have a look at the electronics. My idea was to use an Arduino, but without a PC for controlling or sending the G code. So I added a display, SD card, and some buttons, and a small jog wheel, so that I can do as many functions settings on the local machine without using a PC. So inside we have the RAM's 1.4 board with 4 stepper drivers. I used a very cheap one, but there exist some pin-compatible ones with more power. But for the NEMA stepper motors, this is absolutely satisfying. I added some fans for cooling. I drive the fans over the RAM's board. Under the RAM's is the Arduino. It's the Arduino Mega. And here on that pin header, the LCD display as well as the SD card is connected. So the wiring up to this is very, very easy. I decided to use a power supply which I have from the laboratory, so it can be regulated. I think up to 40 volts. So I said I use the power supply direct to drive the hot wire. So I connect it directly here, and with the RAMs I can regulate with the PWM function the power for the hot wire. The Arduino and the stepper itself are driven or supplied by a DC-DC converter set to 12 volt, and this is here. So there's a little fuse and a little diode inside, so everything is quite safe. In addition, I added a lot of buttons here, so they are connected to the auxiliary contacts here. A wiring diagram is included in the foam cutter inno file. So last but not least, I added the limit switches. They are connected here on the standard limit switch inputs of the RAMs. I need to do some small modifications. One you can see here. I need to cut one pin and bridge it to another one. You will see that also in the foam cutter inno file. This was necessary because I wanted to have some independent timers, and therefore I need to switch the pins to drive that PWMs. In addition, I got some EMC problems on my final machine on the limit switches. So when I traveled, especially with faster speed, I got a limit switch interrupt here on that pins. So I tried to do some software debouncing, but that didn't work very good. So I decided to use simple 100 nanofarad capacitors between the switching input and the ground. This helps a lot, so all my problems were solved. I integrated these as close as possible to the board. So on the bottom side, I soldered SMD 0805 100 nanofarad capacitors directly on the pin header between the signal and the ground. Same I did for the stop button, because the stop button here, the red one on the other side, is also monitored by an IRQ, and the pin next to it is a ground, so I added a 100 nanofarad capacitor there too. In the end I pulled all cables on a sub-D connector. Up to now I've got no problems with that, but I also spent some money to get a good one here because I'm still disconnecting it 5 times a day to do some optimization.